project, we are researching the difference between saturated and unsaturated fats and other various kinds of fats. So to begin with, what do the terms saturated and unsaturated refer to with respect to fatty acids? Well, for the long chains that make up a saturated fat, as you can see here, all of the carbon bonds are single bonds, and each carbon is attached to 2 hydrogens, except for the last one, which gets 3, as you can see right here. Each carbon atom is bonded to the maximum number of hydrogens, and so the carbon chains are saturated with hydrogens, hence the name. Unsaturated refers to carbon atoms with double bonds instead of single bonds, as you can see right here, where I'm circling, because there's a double bond connecting these 2 carbons. It also has hydrogen atoms only on the same side of it in terms of cis fats. Trans fats are different because they have, unlike here where it has 2 hydrogens on either side of the double bond on the same side, trans fats have one on one side and the other one's on the other side. And so they are, hence the name trans fats, meaning a cross. Saturated fats also have straight shapes, whereas unsaturated fats have curves, or like it sort of goes this way and then curves off, as opposed to just straight across. And so to go on off of that, what is the intermolecular force, or IMF, that holds both saturated and unsaturated fats together? The forces holding saturated fat molecules together are called London dispersion forces. Unsaturated fats have weaker dispersion forces between molecules than do saturated fats. This results in lower melting temperatures for saturated fats, or for unsaturated fats, making them liquids at room temperature, while saturated fats tend to be solids. The weaker dispersion forces for unsaturated fats are due to double bonds in unsaturated fats, creating kinks or bends in the shape of unsaturated fat molecules that prevents them from packing closely together, which results in weaker attraction forces. Unsaturated fats have relatively low IMFs because in order for a solid to become a liquid, the IMF must lose strength. If it is held very tightly together, as this evidently is, it is a solid. Which brings us to the question of what is it about saturated fats structure that allows it to have a stronger IMF than unsaturated fats? Well, saturated fats contain only single bonds, so their structures are straight carbon chains. The molecules are closer to each other and packed tightly, which increases dispersion force. However, since unsaturated fats contain double bonds, there are kinks in the structure, which lowers the dispersion force. For an example, partially hydrogenated oil is used to form margarine or added to products like peanut butter. Hydrogenating the oil is a process in which hydrogen atoms bond to unsaturated carbon atoms under high pressure, and in the presence of a metal catalyst such as nickel, it essentially turns them into a trans fat as opposed to a cis fat. And so that's the long and the short of how those things can change from one to another. So you've probably heard on the news about how trans fats and saturated fats have maybe been banned from some businesses or in some circumstances because they are bad for you. Well, they're bad for you because our bodies store trans fat quicker, making it more difficult to burn off in comparison to normal fats. As you can see from the structure, it's just different from how unsaturated fats and cis fats are from trans fats, that it is basically just more, it sticks, so to speak. And that makes it harder to burn off, and it will just basically go straight to your fat areas and just kind of sit there.